Cool. I'm Lewis. I've probably spoken to a lot of you before. I'm CTO at Dataform. My background, software engineer, was at Google with Dan and some of the other guys from our team. Spent most of my time building big data pipelines, not usually in SQL, usually in Java. Same principles, different tools. So at Dataform, our stack is mostly TypeScript, which is basically JavaScript with some extra stuff on top. So we write a lot of this ourselves, not just for the framework, but actually our backend services. Our front end naturally is all TypeScript, JavaScript based. So I've kind of done quite a lot of that. I have some slides, which is going to kind of summarize what I'm going to go through, but I'm actually planning to mostly do this kind of in the app, and we'll actually walk through some things. And obviously, if you have questions, you can kind of jump in, and we'll kind of play around and write a little bit of code and kind of see how that works out. Cool. So a few things I'm going to cover. I'll just go through this quickly. So we'll go through some JavaScript basics quickly, writing functions, constants. I think the main thing that people typically use includes for. Look through some other things like for loops. I think one of the big issues that we kind of get feedback on is understanding how to import and export between files and the magic require method. So I'll kind of try and explain that in a bit more depth about how that works. Some JavaScript specific features which are very useful to understand, like template strings. Then we'll look at how JavaScript actually works kind of in Dataform generally. So what is actually going on in a SQLX file? I think understanding how these things get processed is useful to understanding how to use Dataform. Looking at how to debug some errors, how to use these imports again. And then we'll move on to looking at the Dataform's JavaScript API, which is a little bit different and allows you to kind of programmatically publish tables, create operations, and do some pretty interesting things. And then finally, at the end, I wanted to go through kind of packages very quickly because they're a JavaScript concept and they're much easier to understand once you understand everything above. Cool. We'll just make this a bit smaller. Hopefully everyone can read the small text. Okay, so I've put a project together with a bunch of examples, and we'll just kind of go through them step by step, and I'm going to try of grow on them over time so we can introduce concepts one by one. So just to kind of ground us, here's my first example, and this is just a normal SQL query. So in this project, I've got a sample data file which just defines a load of fake data. And in this example one, we've got a SQL query. We're referencing that sample data set, doing a group by 1, 2, and nothing you're probably unfamiliar with. We're generating a query. It's valid. We can run it and actually see the data. Cool. So there is some JavaScript in here. This is JavaScript. I'm hoping by the end of this, it'll be much more clear what's actually going on when we type this line of code, but I'm not going to do that yet. Okay, so here's my second example. So the idea of SQLX is we want you to be able to kind of programmatically generate SQL files. If you have repetitive pieces of code, you don't want to have to write them over and over again. So we let you run JavaScript inside the SQL file. Anything inside this kind of $ curly brace is actually JavaScript. And I don't know if you've all used them, but Dataform has this concept of JS blocks. There's some documentation on this. When we write a JS block like this, which is just starting with JS open curly brackets, we can write any JavaScript in here that we want, and this will get interpreted as normal JavaScript. And if I make a mistake, it should complain at me. This JavaScript is being run. In this JavaScript block above, I'm defining a function called groupBy. The details of this function probably don't matter too much, but this is some code which is going to generate a list of kind of groupBy numbers. So you've done a big aggregation before. You've probably done groupBy 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be a pain to write. So we can define this groupBy function, which will generate that for us by just if we just give it the largest number. I'm not going to walk through this function in detail. I guess I'll leave some resources at the end on kind of learning JavaScript and what you can do with it. But in this code, we've replaced our groupBy 1, 2 with just this groupBy function, where we're giving it a parameter of 2, and we can see that we've generated the same code as before. This function that we defined above is being called inside the SQL file, like the actual SQL statement, and generating the string for us. So in JavaScript blocks, we can write whatever JavaScript we want. Inside the actual kind of main SQL query, we have this kind of dollar curly brace thing. Anything that's inside the dollar curly brace is also JavaScript. Whatever value that returns will actually be kind of printed out into the SQL that we're writing. And that's how built-in functions like ref work, and we can use our new function in a similar way as well. Any questions on this? Cool. So that's like our first example of using some inline JavaScript in the SQLX file to generate some SQL. Okay, here's another example. It's doing the same thing, but there's a difference here. I haven't actually defined a groupBy function in this file. There is no JavaScript block, but this still works. And the reason it works is we're using an include instead. So we have this includes folder. It's created automatically for every Dataform project. Every file in here is a JavaScript file. And similar to the previous example, I've taken that groupBy function and I've put it in this groupby.js file. And it's exactly the same code. But by putting it in this file, I make it available to all the files in my project. And that's the idea of an include. So as before, we define this function groupBy. There's a very crucial line here, which is this module.exports. Let's see, just ignore this for a second. So this is a concept introduced by CommonJS. Dataform code is actually running in a Node environment. So Node is a way for you to run JavaScript in a kind of server-like environment instead of on a web page. Even though it looks like our JavaScript is going to be running on a web page, it's actually not. When you edit this file, that JavaScript gets sent to our backend, and we run it in a special kind of sandbox process, and then we return the result. So Node.js has this concept of kind of exports, and it's called CommonJS. And this basically tells Node that this file exports a function, and it exports the groupBy function, which is defined above, which means that if I reference that file elsewhere in my project and import it, I'm going to get that groupBy function. So in general, when you're writing these includes, this is kind of the basic pattern that you can follow. If you want to define a function, you can write it, and at the end of your file, you usually have this module.exports equals the thing that I want this file to expose to the rest of my code. So I've put another example of a function here called groupBy lambda. So writing function name, parameters, curly brackets is kind of the standard way to define a function in JavaScript. There's this other way called lambda functions, which is kind of more of a shorthand way to define a function. And if I were to actually take this and put it here, this is two basically identical ways of writing the same thing. So it's useful to kind of highlight, because we'll use Lambda functions in a couple of the examples later to do slightly more advanced things. But anyway, to summarize this file again, it's called group by. It exports a group by function, and we can use that in our project. Okay, so coming back to this this example, we're calling that group by method, and there's something that's kind of slightly unnatural that's happening here. So I'm just going to jump forward to example 4. So if you're writing normal JavaScript, you would see the code as, especially at the top of the file, usually littered with require statements. Require statements allow us to pull functions or constants from other files. And in this line of code, I'm basically saying, I'm asking it to require that includes file that I've created. We're using // to go up directories. So in here, we're in data definitions basics folder. We need to go up to the includes folder, so we can use this // to go back up the directory tree. So if you were writing JavaScript in production, this is what you would do. And that module that exports from the file is now available in this constant called group by, and I can call the function, and I can get the same code as before. Dataform, to make your life a little easier and to not have to worry about that, automatically makes any file in your includes folder available by its file name. So the fact that this file is called group by means that I can just reference it anywhere in this project and it will work. And the idea is just so that you don't have to write that require block and // because it's just it's a bit of a pain in the ass. But it's worth understanding that that's what we're actually doing behind the scenes. So to kind of make this clear, if I rename this like group by 2, come back to my file, it's actually going to complain group by isn't defined anymore because it's the file name that matters. If I rename it back, then everything should be happy. Okay, so we've defined a function, we've put it in an includes, we've referenced that includes by its file name, and we can call that function anywhere in our project. Something that I think I've seen people run into before, which is probably useful, worth mentioning, is kind of debugging. So JavaScript can go wrong and Dataform will throw errors at you, and it's sometimes hard to kind of understand. So I just wanted to kind of walk through the process of what happens if we actually come in here and break our code. So if I come into our includes file and do something invalid, like let's put a / here, this isn't valid JavaScript. There are no errors on the right here because this code's actually it's not actually run in this file, but it is used. You need to go and look at where that code is actually kind of used inside your definitions. So I'm getting an error. It says H is not defined. And that on its own is meaningless. If you expand this, it's actually going to tell you like what line in what file this exception is being thrown. And it's telling me it's going wrong on line 5 of groupby.js. So this is expanding this and actually kind of reading that stack trace is quite useful to understand what mistake you made. And I can come back here and I can see, oh, yeah, this is probably not what I wanted to do. JavaScript won't always give you the cleanest of errors. Sometimes they will be a bit confusing. If I do something like this, I will get an error. But it's not actually telling me where that error has happened. It's hard from the JavaScript perspective, that include file just kind of ended early, and it's not telling me that something went wrong there. So it's not foolproof, but in general, if you do look at that stack trace, you should be able to get some clues as to where the problem's starting. Okay, so this is my includes. Here is my includes where I use the kind of require function. We can require files from anywhere. So we could create a new file called by2 and create a JavaScript file actually inside our definitions folder. And let's take our kind of group by method and put it in here too. Generate this. Okay, so I can tell, instead of requiring the includes file, I could actually require this new file that I've made instead. It's in the same folder as me, and it's called group by 2. And this is going to do kind of exactly the same thing. So you can put these JavaScript files anywhere, and you can require them. They don't have to be in your includes folder, but in general, putting them in the includes folder makes your life a little easier because they will be globally exported, and you don't have to do any of this kind of require/importing step. Maybe I'll just stop for a second, check if there's any questions. I'm probably going through this really fast, I apologize. Cool. Okay, let's move on. Okay, example 5. Constants. So far we've been exporting functions. Functions which generate bits of SQL. We can also have constants. So here's a slightly different includes file, and it's defined in a slightly different way, which is kind of more natural for a set of constants. So in this file, we are exporting this object. If we put something in a curly braces in JavaScript, it's an object, and it has a few different properties on it. One of them is a list of EMEA countries, which I might want to use for some kind of reporting query. Maybe I want to maintain a list of EMEA countries in a single place. For our purposes, that's just 2 countries. And I've defined the string value here, which is like basically a little block of SQL. In our example, we can see that using the kind of $curly brace format, we can actually reference constants.EMEA countries. And the compile query for this is going to expand to country in GBFR. So this is kind of useful for kind of fixed strings that you use across the app. Lists of countries, or I don't know, certain like customer IDs or project IDs. There's a lot of, or specific schemas of external data sets, although you can use declarations for these. But so to kind of actually walk through changing this, what we could do is let's change this to North American countries instead. So I can come back to my constants file, and I can export another property called, let's say, NA countries. And I'll change this to US CN. Is Canada CN?
CA.
CA. Oh.
Got some Canadians on the call as well. That's a rough path.
Embarrassing.
I can confirm.
Okay, so I've added a new property to my exports for my constants. Coming back to here, I could change this to NA, and now I'm getting a different query. So that's cool. You can also, I've called this file constants now. think this is probably one of the trickier things to understand with imports and exports, and I'll share a link on this at the end. I have a page with some links. This is kind of part of how JavaScript just fundamentally works and how common JS works. We can export various things from a file. In this case, we're exporting an object with different properties, and those properties in here are strings. In the group by func example, we didn't export an object. We just exported the entire function, which means that whatever we get from that file is just a function that we can call. We can actually export functions inside the object. So I could export a function called hello. And to do this, we can use the lambda expression, which takes, let's say, a value and turns it into that value plus underscore hello. So this is a function that we've added to this file. And you might find yourself, you might have a file which exports lots of different functions, and this is how you do it. So coming back to our examples here, I could actually reference, let's say, really messed that up. So constants is the file, but we're exporting a property called a function called hello, and I can call it with some string, and you can see the SQL it generated has the underscore hello added. This isn't valid SQL, but the JavaScript is working as we expected. Cool. Okay, next example. Cool, so template strings. Template strings in JavaScript are backticks. Mostly in SQL, backticks don't mean much, except in BigQuery table references, which can be a nightmare. And actually, I think somebody in the school discovered recently that backticks also, can be necessary for some, there's some other things. So backticks in general can be a bit problematic with SQLX. One of the nice things about backticks is whenever you have a backtick string in JavaScript, you can use the $curly brace behavior. And I just used it in that hello example, but to kind of do it again, I can define a new value. I can use backticks, and I could write normal things in here, but I can also write this $curly brace expression. And this is really useful if you want to concatenate strings together. Because I can do something like this instead of having to do something like have one string and then concatenate it with some other value. So it kind of makes the code a little bit more readable. The other valuable thing about backticks is you can't put quotes inside a quoted string, but if you use backticks, you can. So in this case, often in SQL, you'd actually want to generate some SQL with quotes. And if you're going to do that, it's useful to use a backtick string to wrap the whole thing. So I've written 3 examples here. One has no backticks, one has backticks and quotes in it, and another one which has backticks and actually has a kind of a JavaScript expression inside it. So to look at the compile query, you can kind of see how these 3 things are going to play out. So the first one, the field name, is just a string, which means if we put it straight into the select query, we're going to be trying to select that kind of column in the table. It's not a kind of SQL literal value, it's the actual name of the column. This is why backticks are important, because often we want to use those quotes. We want an actual string value. and we can put them in the backtick string. And when we reference that here, now we actually have a string value. I'm using double quotes. I think for anybody on like Snowflake, you probably want this, or Redshift as well. In this example, I have another backtick string, and I actually have a like arithmetic expression inside it. You can see that this has actually been evaluated. These aren't strings. This is actual code running. We're going to add the 1 and the 3 together. Sorry, the 1 and the 2 together to get 3. And then we're going to put that into a string, which is 5 plus 3. And we end up with an actual kind of numerical expression in our query. So these are some of the kind of nuances with generating SQL in JavaScript. TLDR is backticks are really useful, and the template strings are really useful. One point I made earlier is, again, this is kind of where I'm trying to get to with it's not really a reveal, but the entire block of code in your SQLX file is actually a template string. And that's why we have these dollar curly brackets for using things like ref. So in these cases, I'm writing normal JavaScript and I'm using these template strings. This whole thing, when it gets run, is actually going to just be wrapped in a template string, and that's how Dataform basically compiles your code. So we can kind of do similar things in here. Like for example, I could create a string. This is literally just JavaScript of like A concatenated with B, and I can call methods like toUpperCase. And I'm actually going to generate, that code's going to run, and it's going to generate something for me. In this case, I need to like wrap it in quotes. Really valid. So yeah, your whole SQLX file is just a query string, is a template string. And that's, I think, quite useful to understand. Okay. So that's my basics. I'll keep going. Any questions? Okay. So I've just gone on about this whole like SQLX files, our template strings. Dataform has a JavaScript API, which you can use to programmatically create and publish datasets without using SQLX files. SQLX files obviously are, there to kind of make it nicer to write and develop SQL. But if we didn't have SQLX, then this is what you would be writing, and this is basically what a SQLX file gets compiled into. So this is a normal JavaScript file, and we have these APIs which you can use to publish a table. It's called publish. You give it a name, you give it a query, and then this is what I was saying. Like we have this. This is all wrapped in a template string where you can call things like ref. And when you have a SQLX file, it actually just gets turned into a JavaScript file, which looks pretty much exactly like this. So if you wanted to do exactly the same thing programmatically, you can do this in this way. And this is again generating exactly the same query, and it still has like the dependencies, like the refs worked, and we've just defined it via the JavaScript API. Okay, so what is the JavaScript API? There are docs on this. Somewhere in here. So yes, we have some explanations of all the different things you can do here. I'll kind of show the links after. But here's kind of a summary. So there are kind of 4 main kind of types of things you can do in Dataform. You publish tables, that's what you primarily do. You can declare input tables. You can write assertions, and you can run operations, which are just arbitrary SQL and don't necessarily create a table. And here's an example of each of those. So we can call the publish table, the method's called publish. You give it a table name, you give it a query. For declarations, you call declare, and you provide a bunch of options with the schema and the name. Assertions is a similar structure to publish. You give it a name, you give it a query. Operations, same thing. So we can use this API to kind of programmatically do stuff. There are nuances here I'll get into in a sec, but this is just how each of those looks at a high level. Sorry, one sec. Cool. On the right of this file, you can see everything we've created. Usually with SQLX, you only create a single thing. So we just show you one of these cards. In JavaScript, you can have one file generating lots of different actions. We show you all of them. So this is the declaration we made. This is the table, the operation, the assertion. And you can ignore that. Okay, cool. So I want to kind of dig into, I think, one of the most challenging concepts with using the API, which is context. So when you're writing SQLX, you don't have to worry about context. We make functions like ref available to you inside your SQL, so you can just write this. And they're like in a kind of global namespace. You don't have to worry about what context you're in, because this context is automatically created for you, and you just write ref, and it will just all work. In the JavaScript API, because you can do multiple things in a single file, you need to actually think about like the context for the query that you're in. So in this example, when we call the query method, we're using a Lambda function. That Lambda function takes a parameter. I've called it CTX. We could call this context. And then it returns a template string. So the methods like ref exist on that CTX object. If I were to try and just do this, then ref wouldn't be defined. Like ref's not available inside JavaScript code. You've got to call ctx.ref. So this is an unknown or less known part of our documentation, but it's really useful if you plan to write any JavaScript. So we actually have kind of a code API reference, and the iTable context in this reference tells you all the methods that are available. A lot of these will be familiar to you. You just use them all the time, like the ref function, which has examples of like how you can call it. There are other ones like resolve. If you've written operations before, or incremental tables, you might call self. There's when for managing incremental. But the point is, all of these functions exist on that context object. So we could call any of those here. And to like give you an example of that, I could also do something like ctx.name, which gives me the name of the current action, which is, the name of the current table that I'm creating, which in this case is this string I provided up here. So yeah, check out the reference and look at the context objects, and it will show you what methods you can actually call. And using these Lambda functions is kind of important to getting that right. Yeah, this example is just a simple select from. All right, so now starting to put more of this together and doing something slightly more powerful, which is like for loops. So one of the most useful things about the JavaScript API is you can kind of do repetitive code. If you need to create 20 views, which is similar, but like slightly different, it's pretty useful to be able to kind of do that in a for loop. So in this example, I've got my source data set, and I probably wouldn't practically ever want to do this, but let's say I do. I want to create a different view of that data for each country. So this is a great use case for using the JavaScript API. So in this code, I'm going to create a list of countries that I care about: US, GB, FR. I guess if there's lots of Canadian people, we can add CA in here. So for each of these countries, I'm going to use a for each. This is a kind of JavaScript feature. I'll share some links to this stuff at the end. So we can go through the countries that we've got in our list. We can call publish a new table using a template string, which for country data underscore the country code that we're looking at. And then we can provide a query, which is, again, a kind of contextable template string, selecting from our source table where the country equals this current country that we're kind of iterating through. One of the nice things about Dataform, it's going to show you that list of kind of outputs on the right, so we can actually see what it's generating. We've got US, GB, FR, CA. I can see the compile query is just select star from where country is US, and this is kind of different for each table. So yeah, if you're maintaining a list of repetitive tables, this is obviously really useful. If you decide you don't like Canada anymore, you can just remove it, and then it's just disappeared from our list on the right here, or more likely you're just adding something new in.
Hey, Lewis, I have a question on that.
Yeah, please.
I'm curious. So let's say we have a mixed project of JavaScript files and SQLX files, and somewhere along the lines, I have a ref in a SQLX file to country data CA. How does Dataform dissolve dependency of the JavaScript file?
Yeah, so
when do JS files get executed versus a SQLX file in a run?
Cool. Yeah, so all JavaScript is executed immediately at the beginning, like
okay.
yeah, in a single pass. No JavaScript kind of runs after that. So
okay, all right.
There's both like a
so
go.
Yeah, so if I had some JavaScript like this, let's say our publish that query. Well, for example, it's referencing sample data. Well, sample data is in a SQLX file. How does Dataform resolve that dependency and execute that SQLX before the JavaScript? Or it doesn't. I'm just trying to determine if you guys got that magic, or if at some point, if I start using more JavaScript, I have to start to manually work on, dependency execution order.
So when you're using JavaScript and using things like ref, you're telling Dataform what the dependencies are. So in this case, me using ctx.ref inside this publish method has actually added the dependency on sample data. So that means that like Dataform's going to make sure sample data runs before any of this actual SQL.
Yeah, right. Okay.
And like we can see that dependency in the dependency graph. So yeah, in general, like as long as you use refs properly, Dataform should do everything for you.
Right, because really the JavaScript's executing, it's quote unquote publishing the table, but obviously that doesn't do it right then. It's
exactly.
queuing it up in a sense. Yeah. Okay, it's adding it to the graph.
It needs to go and do this. Okay, so that's a good point, because it brings me on to one important point of Dataform compilation. So when this JavaScript's running, it has no access to the database. It has no access to the data. All this JavaScript can do is tell Dataform like what to do. It can't actually do anything. It can't read the data. You can't like read tables from the database. We sandbox all of your JavaScript execution so that like to actually really make sure that this is the case. For example, I can't write code in here which tries to fetch data from external URLs. It will actually stop you. Similarly, like I can't like read from a file system. It's not going to let you do that. And there are two reasons to do this. Like one, okay, I realize it's annoying because there's some good use cases for this. But the main reason is Dataform's compilation it's important to us that it's lightning fast. And generally this is a small project, but I'm changing these files and I'm immediately getting new queries back. And the only way we can keep that lightning fast and making sure that experience is good is to do this sandboxing. Because if you start making network requests or trying to fetch data from the warehouse, it could take like 5 or 10 seconds to fetch, and then like it's just impossible to develop. So yeah, this is a kind of important limitation and kind of ties into what you said. The JavaScript that runs is only able to tell Dataform what SQL to run. It can't read the data, and it doesn't run at execution time.
Yeah, for a second there, I saw that read or sync. I was like, oh yeah, could I run this CSV file that's in the code line, parse it into insert?
So you can actually read JSON files using require, but you can't like read arbitrary text files. It's just like yeah. It's just a limitation.
I think I just saw a new feature of Google Meeting. I had my microphone muted. You guys heard me?
I think so.
And that question I just asked, right, about importing a file, and the red microphone at the bottom started flashing, like bloop, 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 bloop. That's interesting. So I guess I wasn't really muted.
Cool. All right. So that's the API usage. Hopefully, some kind of good examples, and maybe it gives you an idea of what you can do with those like for loops and things. Running out of time. One small note on includes. You can't call the JavaScript API from inside includes. It just doesn't do anything. This code isn't actually executed automatically. All code you write inside the definitions folder automatically gets executed, but inside includes it doesn't. So for example, like this should attempt to publish a data set called won't be created, and it will actually like fail trying to do it, but it doesn't. Like there's no compilation errors. If I move this into an identical file or any file inside my definitions folder, this will actually run, and now this thing that should have never thrown is thrown, and I've got compilation errors. Don't call publish from inside includes. That's only for libraries and functions that you're going to call from somewhere else. Okay, cool. Let me just double check that I've gone through everything that I wanted to cover. So yeah, I mentioned API reference, talked about query context and publishing tables, inline JavaScript, debugging errors. Yep. Okay. So then I'll go on to packages. This shouldn't take too long. So what are packages? Packages are like includes, except that they're not inside your project. Somebody else wrote them, and they live somewhere in some other repository. Like generally on GitHub, they're usually open source, and they package up basically bits of JavaScript that you can call and run inside your project to like do things. So what I was going to quickly do is creating packages is definitely not straightforward, and if you want to do it, I would definitely recommend like chatting to us. But it is doable, and there is some documentation on how to create packages on our doc site, which might be useful with some like templates and examples. So what I was going to do quickly is walk through one of the packages that we've got called BigQuery audit logs. So Dan wrote this, or at least created it. And the idea is BigQuery exports a bunch of audit logs about your project. And it's useful to understand, cost across different users, but the structure of those tables is actually like not particularly great. So Dan wrote a package to kind of clean this up and do it and create a nice data model for you, which is the whole point of Dataform. So I'm just going to walk through the kind of process of installation for this thing. So the first thing we need to do for a package is actually install it. And to do that, for this package, we'll go to the releases page, and it's telling us to add this line to our package JSON. So coming back here, we have this package JSON. All Dataform projects depend on Dataform itself. It's kind of like a requirement for them to run. We can add in this new thing called BigQuery audit logs, which is going to basically say, go and fetch the code from Git at this version number. And once we change this file, if we ever change this file, you need to click install packages. So that's actually installed the thing. Okay, so now it's installed, but it doesn't do anything. Like that installing this package makes the code available, but it's not actually going to run. It's a bit like putting a file in includes. If I don't call that code, it's not actually going to do anything. So coming back to the kind of documentation for this, we need to actually configure the package and call it. So this is an example snippet. I'm just going to copy paste this in. And hopefully, like we've kind of touched on all of these things now, so we can walk through them and then make a bit more sense. The first thing we do is require the package. It's called Dataform BigQuery logs. This string matches this string. So whatever you put in here is how you'd require the project. So that's how we import it, and then this package exports a function. It's like our initial group by includes file that we wrote. So I'm going to call that function with some configuration parameters. I'm going to tell it like my logs schema and some default configurations. And after pasting that in, it's automatically generated two things for me. One is a declaration, which specifies like the raw tables that we're pulling this data from. And then one is a view on top, which like I've got all of this magical SQL, which Dan wrote, and I didn't have to write it myself. But now I've got this nice kind of clean table where I can see data about BigQuery projects and BigQuery costs. So there are a few packages on the doc site. I was more interested in showing you how a package is basically just a function which is going to call the JavaScript API and kind of acts a bit like an includes. So yeah, if you're interested in writing packages or there's repetitive code that maybe you're using across Dataform projects or you just think would be useful, let us know. We'd love to help you kind of contribute and package them up and turn them into something useful. Cool. So I'll share some of these links at the end. I actually don't know where you would go to learn JavaScript. So actually, I mean, I think both these links have been shared by other people in Slack. But yeah, there are a lot of tutorials online for just learning the kind of fundamentals of JavaScript, like how to use constants and includes. I think, Sadat, you mentioned there are some free courses going on Educative. Personally, I like to just get stuck into something new and Google things when I can't work it out. And I think I mentioned this before, if you're Googling problems with JavaScript, it's useful to know that you're running in a node environment, which is going to affect how you like import and export things. And we're using CommonJS for imports, which is a kind of node things. So if you're running into issues around importing and exporting, those are your keywords. And yeah, like feel free to chuck questions in Slack. We're happy to answer. Any questions? Anything somebody wants to do that they haven't worked out how to do yet with JavaScript API, or they can't quite see how they would do it?
I guess I'll ask because I don't know if it's relevant, but a lot of like my complications comes around assertions. So I want to, I'm doing test-driven kind of development, and so a lot of the stuff I tend to do is create helper tables that allow me to then verify certain things in the data set. Can you show an example where using JavaScript might be more advantageous, or creating assertions or tests around using JavaScript may help that process? Because there's some of them, it's like business logic where you're just kind of like, okay, these duplicate IDs, I need to condense them down and make sure all my tables across, you're doing kind of stuff that is not standard, but it'd be helpful not to create another table. I don't know if I'm making 100%.
Yeah. I don't know if it's useful, but like a practical example would be, so we have, was there a specific type of assertion that you were kind of like writing that you were struggling with?
Sorry, I was muted. So a lot of what I do, because we have raw data that people are inputting, is, okay, let me find the duplicates. Now let me say, okay, let me test if those duplicates are in, so for example, location names. The location names are supposed to have a unique identifier. So anytime somebody, puts this location name, it's going to pull up only one record. When we look in the data, that is not the case, right? It's not always the case. So I need to I need to understand which are duplicate IDs and which one is the reference ID. Like I need to go back in time and be like, okay, well, even though this is 226, it links to number 1, ID 1. These are all the same things. So I have to go through the multiple data tables to make sure that they align, so that we're picking out the right information for that particular location. Does that make sense? So it's data quality stuff.
And is that list a relatively kind of small list of like mappings, so like the original location ID?
Yeah, so usually it's only like, for what I'm seeing, it's like 3 different IDs, but then the fact tables get thrown off because you get duplicate in them for each particular. So we have probably 700 locations that have duplicated IDs, but there's only like 1, 2, or 3. So I can kind of choose which ones are probably the most relevant. But I'm doing a lot of manual processing in this respect to clean up the data.
Okay, so I think
and this is a hard one. You can choose whatever example. I just, I was thinking about what I have to do. So if there's a simpler assertion type thing you want to do, that's helpful.
you want to write. I guess it's relatively easy to add a unique key assertion to the table, to the tables. But the challenge is actually cleaning the data in the first place, and you've got to write the same query to like map between these locations across lots of different tables. Okay, so I'll give you an example. Like we have, I think this is relevant. We have a bunch of different tables like about projects or customers or users or various like variations of those tables, and they often have like a user email in them which we use as like a key, and we want to know if those users are internal or not.
Correct.
And I guess this is a bit like turning one country location into like another, say. So rather than like creating a table with a list of internal user emails, we just have a JavaScript function which generates a pretty like, it's not that big, but like it's 10 lines or so of like, if email like Lewis at, then internal. And we basically have something like this for all of our users. I mean, I think I'll share a subset of it because I think it's useful. It kind of gives you an idea. But we use this function throughout our entire project, and it saves us having to deal with like extra tables and joins and like inserts or anything like that. One sec, let me just slightly anonymize this. And I'll show you. Okay, so we have a function. Where is our project? We have a function like this in our project, and it basically generates some SQL for us, and we use it in tons of different tables. And it's effectively one way for us to like kind of clean up and categorize all of us as users inside our project. And if somebody new joins a team, like I can just add their personal email or like some portion of it inside this file, and then they'll be marked as internal in the future. So that's like maybe a practical example. I'm not sure if that quite covers your use case, but it's definitely easier to do something like that, I'd say, than to actually like try and maintain some list, some other table with a mapping.
Okay. I think the issue that I'm trying to think about, because I'm dealing with historical data too. So, things change, and it's like, okay, location. So one of the big things is geographic mapping, right? So each location name or ID has specific information about where this particular location is across the world. So if we have kind of like, hey, we have a scheduled programs, here are where all the kids' programs are, right? And they all say, one might say, hey, this location, which is school A, is location 18. Another person entered the same school, and in their system, because that's what they did it, even though it's the same name, they may have put like, it's a lowercase versus an uppercase. And so it generated a different ID, but they're actually the same thing, right? So, but then they have fact tables that are counting the locations in different areas, right? So there are two kind of things that I'm doing. It's basically like, okay, what is the reference location? So I have to find, okay, even though these are different IDs, this is the winner, right? This is the one that these should be replaced with. So I have to kind of like take the back data, convert that in the new dimension table so that they all point to the same ID, and then also make sure that the fact table corresponds to the winner. And we're using a batch process, so it's a kind of maintaining those dependencies, I guess, is kind of the thing I have to think about. And I currently am doing it with mapping the tables, kind of being like, okay, go here, is this equal to that, and let's do that. But I don't know if that's the most efficient way to do it across these multiple tables that I'm managing, right? So if the reference location changes, say, okay, actually the other one was better, the one with had more information about the longitude, the community it was in, and I needed to switch that to, hey, let's do this one. Then I have to go through and refactor all my tables based on new changes in who is the reference location. Does that make sense? It's a weird.
I think I kind of understand. I probably said that the broad approach you're taking makes sense. Like I think you do want a table for this kind of stuff, like for your source of truth. Like a parallel would be for us data coming from segment. We want to understand. You get multiple user IDs, you get anonymous IDs and non-anonymous IDs, and you kind of want to bring them all together to just assign sessions like a single ID so that you get a better picture of users over time. You don't have duplicates, and we have some logic similar to what you're doing. I think if you're kind of structuring this in a I can't really see not having like a mapping table. I imagine some JavaScript functions, if you're having to then join in this table into lots of other tables, could possibly save some repetitive code. But it would be hard to know how exactly you structure that without like seeing the table.
Okay. All right. I was just asking because.
Yeah, no, I appreciate it.
Yeah, I haven't played around with assertions yet. How do assertions bubble up in the logs, Lewis?
In Dataform.
Yeah.
So assertions are just nodes in your kind of dependency graph. Let's see. This isn't a particularly good example because I don't think I have any. There we go. Okay. Right. So. I don't. Oh, I do have an assertion in here. So I have it. Yeah. So an assertion is just kind of a step in your dependency graph.
Right.
And
it basically runs the query and it puts that data into an assertion table named on that.
Yeah, we actually just put it in a view. We don't materialize it, but
view. Okay. All right.
We create this view with your assertion query, or like the auto-generated query if you've used the assertions in the config block, and then we run a query during that step to just see, are there any rows? If I select star from that table, are there any rows? And if there are, it fails. So that you can kind of think of them just like normal actions. They will fail if the assertion fails, and mark the pipeline as like failed. You can depend on them, so you can actually add them to a list of dependencies, which means if you want to say, if you don't want to create some follow-on table because the assertion on a downstream table failed, you can add it as a dependency and then make sure that you never create this like broken table if it's, I don't know, incremental or something that's hard to change.
Yeah, right. What if you wanted a different flow to execute if that assertion failed?
Yeah. It's a good question.
Or you know what I'm saying, like a fork. So like, hey, if this assertion doesn't fail, this assertion doesn't fail, then do this. If it does, do that.
Yeah. Yeah. So this is, you could do this right now. You could basically create two assertions, one which is like the inverse of the other. And you could have parts of your dependency tree which are
I see, two assertions.
The problem is that if they're direct opposites, your pipeline's always going to look like it failed because one of these assertions have failed.
Oh, right.
So it's going to get upset. And I think that's a concept we don't have in Dataform, which is the idea of some kind of like control block. I would probably say that like, I would definitely challenge the use case. I think definitely I've spoken to people who've asked this before, and usually we've had a discussion and often managed to find an alternative solution to like the problem they're actually trying to solve. Control flow inside your graph, it's just going to make your life really hard to understand what's going on and what's executing and why something failed. And like in general, I'd suggest you want to try and avoid, in the same way that you probably want to avoid operations as much as you can. You want to avoid like too complex control flow at runtime because it just makes it very hard to reason about. So yeah, you can do it, but it's a horrible hack. And I would probably try to avoid it if you can.
Yeah, I mean, I could think of other ways to implement that anyways using SQL, so yeah.
Yeah. Yeah, you can do kind of conditional logic in a SQL statement, depending on the warehouse you're in.
Mm-hmm.
Cool. I think.
Yeah, I mean, the main question I had on that was like, we're going through data, so data quality, I find some bad data. I want to let someone know, right? But I want to continue the flow. And it'd be nice if I do that within Dataform in a sense, but are there restrictions on what I can import, like JS libraries?
So there's no like hard restrictions, but because you can't like make network requests or use the file system, a lot of libraries aren't that useful.
Yeah, all right, there you go. All right, yep.
So in general, I'd say that what you described, like that's kind of how assertions should work. assertions will cause your pipeline to fail. You can set up notifications either via email or via Slack when they do fail. But unless you explicitly depend parts of your pipeline on those assertions, like we'll keep trying to run everything. Like we won't just stop. We'll keep going. We'll build everything we can. So that's the default mode of assertions. Is we'll tell you if it goes wrong, but we're not going to like halt your whole pipeline.
Okay.
Cool. We've run over a fair amount, so I should probably stop there. But yeah, I hope that was useful. I'll share some links in Slack afterwards. Yeah. Cheers.
Thank you.
Thank you very much.
Thank you very much.